YouTube. In this video we're going to go through a few examples of how to find the variance and therefore also the standard deviation for discrete probability distribution. Okay, so in my previous videos we calculated the average for a probability distribution. As a matter of fact, we defined this as being mu, which was equal to the sum of, for our probability distributions, all of the things that can happen x times the likelihood that they actually occur. Okay, we just added those up. I want to point out the formula for calculating the variance. So the first thing we want to mention are a few things here. We say that this is the Greek letter sigma squared. Okay, so it's a lowercase sigma, not like the uppercase sigma here, but lowercase sigma squared, and it's equal to this. Now, you notice here that it is equal to a sum of, I suppose it'd be the sum of this here, so I already got that listed, minus the average. Okay, so a few things I want to point out about this. In terms of this sum right here, it is very similar to the sum that you're seeing over here. As a matter of fact, we in the first instance to find the average just took x times p of x in our distribution and then added all those up. This is going to be the same kind of result, except for instead of taking x times probability of x, we're going to square all of our x values first, or everything that can happen. We're going to square those values first and then take those times the probability of x. But once we're done summing those, okay, that means sum this first, we're going to subtract off the square of our mean. Okay, so we're going to have to know the mean to do this as well. But this is the formula for the variance of a probability distribution. So let's go ahead and take a look at a couple of examples where this applies. So we say find the mean for the number of spots or pips that appear when rolling a die. Well, recall when you roll a die, okay, we say let's write out our probability distribution here and make ourselves a table. We want to keep track of how many pips show up on this die. So we'll let that be x here. X is the number of spots you see on the die, and p of x is the likelihood that that actually occurs. So of course on a die we have 1, 2, we could roll a 3, we could roll a 4, we could roll a 5, we could roll a 6, and each of these have a 1 in 6 chance of occurring. So we write in their probabilities down here. So our job in this case, we said at least to start with, is to find the mean for the number of spots or pips on this die. So we say if this is our probability distribution, let's add in a third row down here. Okay, so this third row down here is going to represent all of our x's times p of x. This is us searching for the mean. So we're going to extend our table, extend it, and actually calculate all these and then sum them. So we get 1 times a 6 is a 6, 2 times a 6 is 2 6, 3 times a 6 is 3 6, and so on and so forth until we reach the end of our table here. So summing all of these 6 together, we say equal the average. Okay, this is the sum of this entire row. And we say this comes out to be sixths, of course, and we've summed this prior to this, but you could check 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. In other words, we get an average value of 3.5 pips. And you know what? This is reasonable. We weren't asked to make a graph on this, but certainly if I did, we could say, well, all the possibilities on a die happen to be either 1 through 6 here. So 1, 2, 3, 4, 5, 6. Okay, and we say their likelihoods, well, each of these had a 1 in 6 chance of occurring. So I'm just going to make my y-axis here, which are all the probabilities of it occurring, just be like, hey, 1/6, 1/6. Let's rewrite that, 1 divided by 6 and 2 divided by 6. Not that I had to go up to 2 6, but I will. So each of these has a 1 in 6 chance of happening. So when we look at this distribution, we say, well, the average number of pips is 3.5. That's entirely reasonable. So here's going to be our job today. Now, what I want to consider is this. So what is the spread of our data? Because of course, if I were to make another distribution where we'd say, you know, it's 1, 2, 3, 4, 5, 6. We'd say this is 3 and this is 4, and 3.5 is of course in the middle. If we said this was our distribution, you know, somehow this is really kind of crazy. But I would say this would be kind of the same idea. The average would still be 3.5, but you notice that the data is spread a little bit differently. And over here we have a smaller spread, whereas over here the data is a little bit more spread apart. So when we find the quote-unquote spread of a data set, what we're searching for is the standard deviation. Okay, so I want to mention a few things here. First of all, the standard deviation. Let's write this down. The standard deviation is equal to the square root of the variance. Okay, and so if that's the case, what this means is we're actually going to have to be proficient at calculating the variance so that we can get the standard deviation. And the formula for the variance is listed up here. So we're actually going to put this formula into use for the very first time. As a matter of fact, what we're going to do is we're going to add a few columns onto our table. So let's see if I can try something here. What if I get my black marker out? I'm trying to, ooh, that works. 30. Let's get this out of here. Just kind of, I need to extend my table a little bit. It's kind of a cheater's way to do this. Sorry, oops. All right, so we'll switch back over to a different brush here. Very, very light pencil tip, as a matter of fact. I'll try to at least. Brush, assorted brushes, default brushes. Ah, here we go. So 9. Oop, we're still on black. Let's go back to green. Not bad. I think I'll go with a 3 here, 3 point. I like the fine tip. Okay, so here's what we're going to do. Maybe a 5. We're going to add in a couple more rows. As a matter of fact, we're going to add in a row at the top. We're going to add in a row at the bottom. If you're observing this formula for variance of a probability distribution, notice that we need squared x values. So up here, we're going to add in a column for x's squared. Just like we have in the past with probability distributions, to find the standard deviation, we had to square all the x values. So for instance, 1 squared is 1, 2 squared is 4, 3 squared is 9, and we get 16, 25, and 36 respectively. Okay, so now we're going to add in another row down here where we have to take x squared times p of x. Okay, so we still have all of these probabilities listed right here, but in this instance, we're going to take all of these squared values times the probability. So instead of taking, say, 1 times a 6 to get a 6, we're going to take this squared one up here, 1 times our 6th, and get, well, a 6. But when we take now 2 squared times a 6. In other words, x squared times the probability would be 4 times 1/6. We actually get 4/6. And we get 9 times 1/6 is 9/6. So we'll proceed to do this again. We say 16 times 1 out of 6 is 16/6. 25 times 1 out of 6 is 25/6. And last but not least, 36 times 1 out of 6 here is 36/6. So just as we did previously with our average, we're going to now sum these values down here. So we say the sum. I'm just going to write this right here. But the sum comes out to be still sixths. But we have to add up all the numerators. So let's see, we got 1 plus 4 is 5, plus this is 14. 14 plus this is 30. 30 plus 25 is 55. 55 plus 30 is 85. And 85 plus another 6 is 91. Okay, so we actually are going to have to get out a calculator on this one. It's not a huge issue. It's really more about knowing how to get this number in the first place. So we get 15.16 repeating. So I'm going to write approximately 15.16 repeating. Okay, so now we're all set to find the standard deviation of this, but we're going to have to find the variance first. So the variance, let's go ahead and write this out. We say the variance, which is sigma squared, is equal to this. We are going to take this number that we just found, 15.16, and we are going to subtract off the average squared. So we do know the average. As a matter of fact, it's 3.5. But we're going to get our calculator back out. As a matter of fact, oops, if I don't lose it first. It's a little bit odd of a calculator. In a regular calculator, I type in 15.16 minus 3.5 squared. But we're going to have to square the 3.5 first and take it away from this. So we say 3.5 squared, okay, 12.25. So we get this, 15.16 minus 12.25. 15.16 minus 12.25. So if we were to take that 15.1, I'm going to put in a few sixes here because we had a few, minus 12.25, we get an approximate answer here of 2.916. Okay, so we're going to say this is about 2.916. We'll call it about 2.92. Now, keep this in your back pocket because what this is the variance for our distribution. And remember, we said in order to find the standard deviation, we actually have to take the square root of the variance. Okay, so now we need our calculator to tell us, well, what is this, which would be the square root of 2.92, which is approximately, and since we have this out here, let's go ahead and pull it back out. If we were to take the square root of this, we get about 1.71. So 1.71, and what I want to do is I want to label this. We're going to call this, just as we did our average, pips. So in other words, what we just discovered was this. If you look at your distribution up here, we say we had, on average, 3.5 pips. So our average was right here. We say this is our mu. But on average, we're going about 1.7 steps away from this. So if we were to go 1.7 steps below this, it'd be about right in here. And if we were to go 1.7 steps above this, we're saying that our data lies on average about 1.7 steps each way from this. So that's a not so quick example of how to find the variance and standard deviation for a probability distribution. In my next video, we're going to work through these next two examples a little bit more quickly. Okay?